somebody. That's fine. All right. All right, this is gonna be the second half. So output pathway, the last one key pathways to go to air dispersion modeling, the air mod. So basically, in the output, you're gonna choose what results you want to see. So we'll talk about what is these high first, high second, high mean, and you also can create some special output that you want the model to tell you, like a plot file that can create a contour plot, maxi file. The maxi file will basically help you to do frequency of exceedance analyses, a max decount. It's kind of like for some special processing for the new statistical based, like 1 hour SO2, 1 hour NO2, or 24-hour PM 2.5. And some file is like, it's not required, but we usually output that because this is a much shorter version of output. It just output, starts with a very long input details and intermediate calculations, and then the results is like pretty much like last 5% of the document. That basically takes that out of it. I like that file a lot. So what is high ACE high? So it's always being very confusing. High ACE high, what the high talk about? So let's look at, think about this is one receptor model. You don't have high ACE high. You just have like first high, second high. No, this is our 1 through 9, and you can actually rank it. First high being the 67, second high being 64. So eighth high is the pretty much, in the reality, you will not only have just 9. You would, if it's a, daily, like a daily maximum, you'll have, like 365 daily maximum, 365. And 24 hours and 24-hour, average, it's also, 365. So ACE high is this. So what is the highest ACE high? So this is only one receptor, think about that. So in the model, you won't have only one receptor. You have a full 3,000, 4,000, 10,000 receptors. So highest ACE high, like every receptor, you do this rank. Well, only show 3, but in reality, you will have thousands. And then every receptor, you find the highest, the ACE high. Now, highest ACE high means like among all the receptors, which one's highest? So that's what highest ACE high. This kind of like get me really, confused when I first started to do modeling. But kind of like once you get it, kind of like understand it, okay, that's clear. So what is the design value? 24-hour design value of PM 2.5 is the maximum average of the annual 98th percentile of the 24-hour averages, and 98th percentile itself is a high ACE high. So this is almost saying maximum average of high ACE high. What does that mean? So on the receptor 1, you actually define that the maximum average is basically a 5-year average, or it could be a 3-year average if you use 3 years of metadata. 3-year metadata prognostic, right? It's kind of new concept, but usually we do 5-year. So all like so that high ACE high is determined from here, right? This is receptor 1, and all the number like 5-year average of the ACE highest. Like this is the ACE highest of the receptor 1. The average is this, and you kind of like for this you can actually take the average of the 5 years different numbers and get this is your average. So that's the PM 2.5. Downwash. Okay, so that was output, and downwash structures. That's also a key part to the the source setup, the model setup. So the project has point source. We need to include downwash. So that's kind of like something we also get confused. Is do I have to run downwash every time? The answer is no. If you only have volume source, like say you are only modeling equipment fugitive leak, a fugitive leak from like an equipment light, you only have volume source, area source, you don't have, stacks, no need to run downwash. Well, to just start it like how I was trained in, like my old company, they will say, always run downwash, always run air map again, always run downwash again, when you change anything. Not true, but it's safe to do it. So that way, that makes it easier for people to QA/QC. Okay, no matter what, you have rerun the elevation and rerun the downwash. So I know the downwash is there, but not necessarily. So there will be rectangular buildings, polygon buildings, circular buildings can be put into the model. They will affect how the plume acts. It will be downwash to the ground. And they, for volume source, the second bullet point talk about, the volume source also have downwash, but it's already accounted for when you are putting the, initial vertical dimension. So you don't have to specifically do downwash. And we also talk about these structures. It's tricky. When I first started modeling, I always put these in as downwash because I don't know. So I would assume, to be conservative, I better put it in than not put it in. But the wind will be able to go through the bottom of the structure. This is a tangle, doesn't look very clear, but you also, I couldn't find, I would rather use like those ammonia, kind of tanks, like the sphere tanks. And you have, airflow, goes through it. But I searched our company's database, they don't have that picture, so I just grabbed something similar. And that hollow is thin, just like as long as the wind can go through. The current practice is don't put them into the building downwash. However, you would argue that wind would be blocked by some of those little hollow structures anyway, right? So EPA and, they form a group, they are researching a new building downwash program, Prime 2. There is a group I know they are trying to rewrite the whole BPIP because you will notice AirMod is released almost every 1 or 2 years. AirMet is doing every 1 or 2 years. AirMap is also updating. You have the version, AirMod is 22112, means 2022. 112 is the 112th day of the year. They were thinking about actually to name it 22222 to make it easy to remember, but there is, we kind of like say, it's like too boring. So they took our, their words and didn't make it 22112. And they tend to do it pendulum, like 18081, those kind of easy to remember. But you notice AirMod, AirMat, AirMap, all is like updating in the recent year, but BPIP, the building downwash, is always 04, something like 272, I remember. So it's the 2004 version. It's been 19 years old, hasn't been updated, but they are looking at a new BPIP in the near future. So that will account for those kind of structures. Something, not, yeah, something interesting. So, but before click run, or if you are belonging to the coding, kind of like a community, you are, running AirMod on your command line, before you hit enter on your, executable, definitely check these. Check if you have elevations on every object, source, building, receptors, and run air map. Make sure you run air map, and air map density. Data the national elevation data can be downloaded in the, MRLC that we just showed earlier, that, where you download the land cover as well. And make sure you run BPIP. I mean, if you are sure, you don't have to run BPIP, you don't have to. But if you're not sure, just, this is really quick, like 10 seconds run, so wouldn't bother. Okay. That is pretty much all the model setup we already talked about. So the second, really the true second half is what that in the regulatory modeling procedures I'm going to talk about. This is actually probably less intense than the model setup. So now you learn, like we talk about how to set a model, how to set different kinds of model. And now this is to try to answer the question, how the state agency, how EPA wants you to set up the model to be comparable every, one, apple to apple comparison. So for criteria pollutants, for NOx, NO2, SO2, PM, 10, 20, 25, and CO, right? These kind of things, and also lead. They are called criteria pollutants. They have a system of the national ambient air quality standards associated with them. We call it NAAQS. So to start with, we'll first do a significant impact analysis. And the next steps will be, if that one passes, okay, that's good. If it doesn't pass, move to the second level, full impact analysis. Full impact analysis includes the NAAQS analysis and the PSD increment. This is for major project only. This is, major and minor all need to do state NAAQS. And if these still have problem, you will have the cost and contribution analysis. So significant level, you can understand it as a de minimis level. And basically, we understand that if your project impact is below the significance level, you're not expected to cause a significant kind of contribution to anything, any NAAQS or what appears to be increment, exceedance. So you don't have to continue the model. And why is that? Because like there are people, there are environmental activists, and the people will be arguing. If you have small projects here and there, this project has like a 1.2. That project has 1.2. Another project has 1.2. They add up. Will quickly add up to 35, right? Not exactly like that, but that's kind of like the point that people go lobbyists and trying to have the government and making more stringent policies. Like at a certain point of time, the PM 2.5, I put like a recommendation here, is that they were used to be, they don't agree with that approach. So at a certain point, like about I can't remember exactly, like 3 years ago, we are not allowed to use the seal unless you justify why you think the seal is correct or it is applicable to your project. I kind of feel like pretty interesting, because this is what EPA recommended, and now you're saying in every of the project you have to, it's on applicant responsibility to prove EPA's recommendation is correct. I mean, but now they are finalized. But now we can use 0.2 and 1.2. I mean, for PM 2.5. But okay. So now coming back to the question, why we think you can have this project 1.2, that plant 1.2, and everything. Maybe you have 100 plants of 1.2 is okay. It's because the significance level. EPA had, some research group come up with these numbers. These numbers are actually intended to be like within the acceptable noise. So, kind of like their accuracy, their kind of like measurement accuracy is not as accurate as you think. Like you can say, I measured today's, or like this year's, impact, kind of like a monitor concentration, maybe 25. But that 25 its accuracy is plus or minus 1.2. So that's why, kind of like, and all the projects, they are actually, split and spread it out to the whole area. It's not going to be, 1.2, 1.2, 1.2, 1.2 at the same location, but they are 1.2, 1.2, 1.2, 1.2. They can actually, when they kind of like emit the emissions, like having 1.2, the 1.2 is very close to their own boundary, and then outside, it's small. So that's why that's the basic idea behind why if you are smaller than significance level, you are okay. So the table also shows some, primary NAAQS and secondary NAAQS and the class 2 increment. There is also a class 1 increment, the increment that allowed in class 1 areas, but we very seldomly use those. There was a class 3 increment, but we no longer have class 3 areas in the United States. Pretty much everywhere is class 2, except for those national parks, those are class 1. So, and then we talk about years of, in the regulatory modeling, years of metadata to use. For major source, you trigger PSD review, no choice. You have to do 5 years of National Weather Service data. That's kind of like collected from airports, those data. Or, you can do 3 years of prognostic data. That's model predicted, kind of like you have WRF data, WRF weather model and you first create a WRF, weather model, and use that, put in a program called MMIF, and to create a 3 years of, air model ready prognostic data. This is only used in somewhere you don't have the National Weather Service collection data, and then you use that. Or you can use 1 year of site-specific data that you said, okay, before construction, I'm gonna do 1 year of on-site meteorological data collection. And that's good. That's good. Not many people do that. It's a year. Nobody would really allow a year of lead time before you barely can start to do modeling, right? And you cannot guarantee that year of data will give you good results. So that year of time investment is very prohibiting. But it's allowed, like in the regulatory, you can do that, but I haven't seen anyone do that. I may have seen one in like about 10, 12 years ago when I first started to be modeling in Florida. I have seen one project, they said they have on-site data. I thought, okay, so on-site data is pretty common, but after that, I have never seen it. And for minor projects, we're applicable. Like, in Louisiana, apparently, you don't do modeling for minor, modification of air permits. And if the state wants you to do, they'll ask you to do it, but seldomly it's the case. So, so Louisiana, we wouldn't, submit, just like in advance, just like, but TCEQ, you have to do modeling. That may change because the EJ, there are people starting to just submit a modeling, analysis to LDEQ as well. So, hey, we did this. We showed our impact is below, we're meeting national air quality standards, and we're doing this for EJ and a goodwill. So that can change. Okay, so back to significant impact analyses. We're going to talk about that. It has lots of synonyms. So it's called significance. It can be called significance analysis. Significance run, or de minimis run, preliminary analysis. I hope these are not too confusing because later there will be an air toxics model and it has very kind of different synonyms. Like the synonym doesn't look like they are actually the same thing, but this is a little easier. But so what you're going to do? So the project significant, this model, we only put in the project news sources project modified existing sources, those will be into the significance model. That's basically your project. And you will put, proposed allowable emissions. Or for here, you probably, for the project modified existing, you actually can just put in the delta. And in some cases, you can also, like if you remove the source, just for this project, you can actually model a negative emissions for significance. It's a little risky, but it's accepted. Risky being, like the state agency may have some questions, trying to challenge you on that, but it is accepted. Non-project sources doesn't need to be in this run, and for that we are looking at everywhere, looking at the first high values. If you model 1 year, look at the 1 year's high first high. If you run 5 different years, you need to look at 5 years highest high. And then you become comparing that to the ES level. This is how you look at the data. I mean, for significance impact, it's pretty straightforward because you're just looking at the maximum. But in case you are running 5 year of met data for PM 2.5, for NO2, for SO2 1 hour, NO2 1 hour, they're actually looking at an X year average of the high first high. So it's not looking at the maximum of the 5 high first high, but it's look at the average of the 5 high first high. So, to make it clear, it's like it gives you some break, So for lead, if you had to do lead, there's no SIL, so you don't have this significant analysis. Go directly to the full impact analysis. I'm not going to say very rare, but it is rare. I have done 1 or 2 projects over the past maybe 10 years. So the significant impact analyses. So once you get everything set up, run and get the results. If the results are less than the SIL, the significant impact level, this table, the significance level, you're good, done, happy. But very seldomly you have that luxury. So otherwise, then your next step is, take either the contour plot file or other graphical utility. I mean, basically all the major commercial, graphical user interface will let you select, this is your center of the point, your project. And by looking at, actually the program will look at the plot file and it'll draw a circle called ROI, radius of influence, radius of impact, something very similar, terms. And, kind of that basically is the distance from the center of the project to the farthest receptor that has exceedance of SIL. That ROI, that the radius of it should look like a circle. However, it's not every receptor in that circle is exceeding, the significance level. So all you need is to just collect a sub-series of the receptor that are exceeding the SIL. Use it for the next runs. So if you have multiple years of metadata used and a separate model are run, you probably need to define an ROI and the receptor grid, separately for 5 different years. But also there is another easier way to do it. It's just like use the largest AOI, use the largest kind of like more all-inclusive receptor grid. Makes your model setup a little easier moving forward. So this is how it should look like. I mean, I'm just draw it. This is the facility boundary, and there are some receptors that still exceeding the SIL, and you draw. That is your ROI. That's only for view purposes. That has nothing to do with model. The model will take all the blue, you probably see it black, the receptors into the next full impact analysis. Okay, so for impact analysis. So first we talk about what to model. So it's the project sources, new and modified should be in there, and other on-site sources. That not modified also needs to be in the model. And also you need to be having some nearby sources. Traditionally, I'm talking about very traditionally, like, and also this is written in the, the modeling guidance, EPA's modeling guidance. They'll say, you need to include all the sources within your ROI plus 50 kilometers. My goodness, that's a lot. But recently, they are too conservative for the new, standards. So, kind of like, so now we are kind of like a little loose on that. If you really get into that, you'll get the nearby sources within, let's say, ROI, just ROI, or ROI plus 10, plus 20, talk to the state agency. But this is only for the, I'd say only for the major projects. If you trigger PSD, you have to do this. If it's a state minor NAAQS analysis, this is a little tricky. You don't really need to include any nearby sources, and but you still need to do something. We'll talk about that later. And all the emissions need to be modeled at the allowable level, but there are some variations allowed for these nearby sources. Your source, project source, and other on-site source will have to be at the allowable level. But for the nearby sources, there are some variation you can use. So we can probably go to the next. Let's finish this. So how to compare the results? You have your model results, and you need to add a representative background concentration, and then to compare to NAAQS. Not that unlike SIL, the significance analysis, you just compare your model results to the SIL. But for NAAQS, you have to add the background plus your model, the impact from all these things above. So if it's less than the NAAQS, you're good. If not, you need to do cause and contribution analyses and see what you can do, right? So trying to translate some standard language. This is from the NAAQS standard language into modeling language. Okay, so if you're looking at something not to be exceeded, that means high first high. If you're looking at something not to be exceeded for more than once per year, okay, you can have high second high. 99th percentile of a year. This is usually on like a daily thing. This is for 1 hour SO2. It's kind of like the annual distribution of daily max. So it's kind of like 365 days of data points, right? So 99th percentile pretty much, counts from the top to, like 1% of 365 days. So look at the fourth high. 98th percentile of a year is eighth high. And here is something called like not to be exceeded more than once per year, on average over 3 years. This is basically a this is coming from I'd say this is coming from PM10 standards. And if you only model 1 year of metadata, you'll be looking at the second high. If you use 3 years, basically, you can basically exceed 1 time every year. On a 3-year average means for 3 years, you can have 3 exceedances. And this 3 exceedance doesn't have to be split into 3 different years. It can be all in 1 year, right? And so if 5 years model, you will be looking at the 6th high. This is basically how so I probably didn't update that last night. So for CO, these 1 hour and 8 hour, these are not to be exceeded more than once. So you actually could use high second high. For NO2, this is X year average. Like if you model 5, it's 5. If you model 3, it's 3. If you model 1, that one single year. But that's ACE high for NO2. Annual would be just basically, there is no first high, second high, because there's one data point for a single year. PM10 is, if you model 5 year, high 6 high. If you model 1 year, high second high. PM 2.5 is also 98th percentile. So you can go to high ACE high. Annual is basically the highest X year average. SO2 is 99th, so 4th high. And 3 hour is not to be exceeded once. I mean, this is two is different. 1 hour is a pretty new standard, the 99 percentile, 98 percentile, but the 3 hour is a not to be exceeded more than once kind of type of stat, the thing. Lead is a 3 months rolling average. So yeah, that one I basically just copied from the other and didn't update that. Sorry for that. But lead is a 3 months rolling average. You can get the first high months, and you also can do there is a program called lead post that actually post processing your month's data on a 3 months basis. When using 1 year of data for the previous is talk about you are using the full spectrum of the data, like 5 year airport, 3 year prognostic, or 1 year site specific. But for state NAAQS, you can use just 1 year of airport data. But that TCEQ said you would use high first high for everything, so that be more conservative. They are not sure. So this is the value that you want to. In some cases, you will use 5 years of metadata for state NAAQS as well. So that's state NAAQS. It's not necessarily say you have to use just 1 year, but you can use 5 years if you want to. And this is why sometimes you want to, because a project I did over the past couple of years, their NO2 is always a troublesome. Even though it's a state minor NAAQS, we use 5 year metadata. That way we can look at the ACE highest, not always the first highest. And that the first 7 sometimes are pretty bad. Full impact analysis. Okay, so let's see. So this is kind of like a supplement, information to what kind of emission rate you use. So most conservative always, you do the, maximum allowable. Looks like this is basically, okay, so I must meant to pull that last couple of lines to here, but I didn't do cut and paste. I didn't copy and paste. So next slide. This is Appendix W. So this will talk about some, variances you have. So then let's look at nearby source a little bit. So this is for you will be kind of like looking at their permit. You find their emission limit. Emission limit will be maximum allowable emission limit or federally enforceable permit limit on annual, the same thing, but times their operating levels, kind of like you're doing their permit again. I mean, this is a very cumbersome process, but in case you have to do that, this is the guidance, like kind of like a backup that you can do it. Like, see, this is the annual level when actually operating averaged over the most 2 years. Like their operating level may not necessarily be their permitted capacity. They say they have a 300 MMBTU boiler, but they're only firing it, say 150. You don't have to be penalized by them staying permitting at a higher level while they are not actually doing it. So that's kind of like the idea, for nearby sources. You will have the opportunity to do something for NAAQS this is also new, like about like 5 years ago. And before that, you have to just do same as a proposed major, like design capacity. You know, like if this is designed as 300, permit as 300 MMBTU, you model it that way. So something, you know, this is Appendix W, you can take a look at it. Okay, next, you know, we talk about the model, right? You know, model, you know, input, you know, your source, project source, not project source, nearby source, and the next, you know, part is the background monitoring data. Where to get background monitoring data? Easiest access I always use is the EPA's air data monitor values report. So you go to this website. You know, here is the link, and basically you tell them what pollutants you want, the air and the work area, and the run. I would do exclude exceptional events, because you know exceptional events you don't always, you don't need to have it. You can do include, being more conservative, but after a few years of, you know, like I'm doing modeling, I figure why do I just like did click this and click that doesn't, you know, does not kind of like differ too much of my effort. You just run and select. I would always use exclude for now, and other sources are also available. This run will basically run and tell you, okay, that year's high ACE tide is how much. You just use that. But if you're not trusting that data, or that data may have some quality issue, you can go to TCEQ. You have every hours of data, and you can do your own work to figure out which is the high ACE high or annual average. You can do that, but not much, you know, kind of like project will call for that, you know, thing. And you know, after you know, this is a special treatment of PM 2.5 analyses. So for PM 2.5 analysis, all you did, like your project, your not project, nearby, and your background all add up together. There's a secondary PM 2.5 to account for. And you would use some tool called modeled emission rate of precursors, kind of like secondary formation of PM 2.5. They are not directly emitted from the stack. They are formed in the atmosphere through reactions, like photochemical reactions, from some precursors. The precursors we are modeling will be NOx and SO2. So it's like some equations to calculations, and it's not too difficult, but you know, it's still like maybe a few equations to calculate if you are interested. The TCEQ guidance has it, and the EPA has also a MERP guidance on it. But the easiest thing I found is use TCEQ's form, the modeling report form. They call EMU workbook, electronic modeling evaluation workbook. They have a tab. Just throw in your project increase, you know, select what kind of, you know, kind of like, you know, in the database you want, and it'll just pretty much calculate. You know, it does all the calculation for you. So this is kind of like where you can, you know, like, you know, have some, you know, like, you know, off of some, you know, responsibility, you know, kind of like be a little easier to doing that. So some other topics on, you know, the next analyses, the intermittent source guidance, like some source we are, it's not kind of like a continuous, you know, operation. So something like this, emergency backup engines, you know, kind of like you usually are doing it 1 hour every week. So annually you have only 52 hours, but that hour, the NOx emission, NO2 emission or SO2 emission are pretty high. And that can hurt your, you know, if you model that maximum for your hourly emission, hourly impact analysis, it's probably going to make a big contribution. So there are some, you can use, in TCEQ, you can use an annualized emission, basically just 52 hours, divide that, even distribute it to 87, 60 hours, And that will pretty much, like kind of like kill that, impact. You're pretty much looking at almost a 100 times lower emission rate to the model. And EPA's guidance sometimes they allow if you provided enough justification and backup, they allow you to not model those sources. But TCEQ would like to see some model anyway. But be very careful that the intermittent source guidance is only for 1 hour NO2 and 1 hour SO2, and it's not for 3 hour SO2. I have been seeing a lot of cases that people just use the average, like kind of treated emission rate for all these, but like they use it for 3 hour SO2. That's a no. For the SO2, state property, the Texas state property analyses, TCEQ will kick it back to you, and not for PM 2.5. It's only for 1 hour NO2 and SO2. For PM5, what do we do? PM 2.5. If you only run it for 1 hour per week, but you still want some kind of like adjustment, not to model the maximum 1 hour maximum to the model, you still can have something to do, because PM 2.5 and also PM 10, remember it's a 24-hour standard. So you can use an average 1 hour divided by 24, that's a daily average, to put that in the model. And something to consider, to be considered intermittent source, annual operating hours less than 200 is TCEQ's word. EPA's word is less than 500, but TCEQ wouldn't buy that. So anything, you work with TCEQ, it's kind of like, in between 200, 500, it's a kind of like an argument, with TCEQ. And, also consider other considerations. Some state minor NAAQS, Texas procedure. So that's special to state NAAQS of Texas. So nearby source, they said you can represent that in the background monitor. So you don't have to do that nearby source search, the ROI plus 10, ROI plus 50. You don't have to do that. But they will ask you to do some 18 months permit search. So that, make sure those authorized source and not built are captured in your model analysis. And of course, you need to do some justification of your monitor. And, can use, the full metadata if desired, sometimes help you don't get the H1H, we'll just talk about. So here is the justification of background monitor. And unless your monitor is less than 10 kilometers away from your site, you need to, sometimes the closest monitor at about like 20 kilometers or 50 kilometers to your site, TCEQ will not buy that it is the most representative. You still need to do the, emission comparison within that, like a 10 kilometer, and need to do the type of nearby source, county emission comparison, county population, and some land use consider lots of different documents to do. TCEQ is definitely the by far the most difficult state that, to justify a monitor. I mean, for some reason they have the monitor site there, they will ask you to justify the use of it. Full impact PSD increment analysis. I mean, that's nothing to do with state minor. State minor, you don't have to do PSD increment. Increment is only for major projects. So I'm gonna go real quick on this, because so all the new or modified project sources you model at PTE because you haven't built them yet. But for other sources, you can use actual emissions. And the baseline emissions is when the baseline date is, look at that emissions over that time, and it can be used as negative. And it's kind of like, there is increment consuming and expanding. That's kind of like if a source exists at the baseline time and it's being moved, that is actually expanding your increment allowance. But if there is the source has not been in the baseline time, it's added later, it's already consuming increment. So you have to remodel that. Increment is special on, you have to model them year by year. It's not like you can model all 5 years together like NAAQS. And because of that, it may need to, if you run the SIL for 5-year metadata, you probably need to run a special SIL for increment if that's the case. You need to do increment analysis. So increment is also not to be exceeded more than once. It's kind of like a pretty old standard, hasn't been updated since like 10 or 15 years ago. And if the results are less than the increment standard, you're done. If not, cause and contribution analysis. So cause and contribution analysis basically is looking at every single receptor. See if on that receptor at that time, because all the receptors you put into the full impact analysis is already determined, have some chance to exceed the SIL. That's your SIL, kind of like your significant receptor. However, it's not on every time, every hour it's exceeding. It has maybe different times. So what you need to do is to make sure to find out on that exceeding time, for example, on a certain hour, it's exceeding NAAQS or exceeding PSD increment. However, your project on that hour is not over significant level. That way you can demonstrate you are not causing or contributing to this exceedance. However, TCEQ doesn't like that. I have done projects in Louisiana and other states using this approach and well received, but I had a few projects dealing with TCEQ. They don't like it. They want you to, no matter what, either they will help you to refine your nearby source inventory, or they will ask you to reduce your emission to not touching this cause and contribution analysis.
Have you done any in Colorado?
Mm-hmm.
Have you done any modeling in Colorado? They're really big on like emissions.
I haven't done Colorado modeling, but their modeling lead, they have a new air kind of like an air director. He used to work for GHD, and we are, we know each other very well.
Yeah, I remember. I think I talked to you yesterday.
Yeah, Sergio. Yeah. So he understands this cause and contribution analysis. He will approve it, I'm sure. Yeah. So I think this is the last part of the presentations. Air toxics. Air toxics have all different names in Texas, called MIRA analyses, also ESL analyses, or health effects analyses. So all these mean the same thing. So don't get confused. And MIRA is basically stands for this, and they only use 1 year metadata. You was first comparing, we basically comparing to ESL, and also note that ESL is not like a standard. It's a guidance. So if you over that, it's not the end of the world. Okay. So the key steps in the MIRA, analysis steps, I usually, look at pre-step 3, kind of like if you can get de minimis or screened out, like if your emission is below 0.04 pound per hour and your ESL is at a certain level, you can screen out. You don't have to even evaluate. But I usually go directly to step 3. But because pre-step 3, I think it's pretty much, permit calculation, those kind of like a, responsibility. But step 3 is a project only. You are doing you need to run a model with all the sources at 1 pound per hour, and set source groups get their impacts, And that's called UIM, Unit Impact Multiplier. Basically, that means of 1 pound per hour of this stack, what the impact will be in microgram per cubic meter. And use that times your pound per hour emission rate. That is basically that source impact. Add everything up. You actually lost some air mods refinement because you know, it's adding worst case plus worst case, every worst case add up together. So, but this is what TCEQ want. If you really do refined modeling, considering all the, you know, time and spatial, you know, distribution, they will say this is not step 3 modeling, this is step 7. So if the step 3 is less than 10% ESL, you're done. If not, there are step 4, step 5, step 6. I don't usually use them. It's very confusing and not very well defined. I usually just go direct to step 7, do the site-wide modeling. And, you know, we can first use the UIM approach to basically, again, use that number. If it's less than 100% ESL, you're good. But, you know, you can also use refined modeling to get a better results. And of course, the frequency of exceedance analysis. I actually borrowed some slides from my previous, you know, presentation that, okay, so this is, I'm gonna go quickly over what kind of we do. Basically, we calculate this, and then, you know, we compare that, you know, we compare to the ESL. ESL is pass, good, not pass. We do a site-wide modeling, but we set up a frequency of exceedance analysis file called maxi file. From there, you can, you know, you can run the 1x ESL, 2x ESL, the analysis, kind of like creating this table. And this is basically you give it to the state, and you know that's about it. And some more analyses, some visibility, growth, and the soil vegetation, class 1, environmental justice. We're not going to cover it today. All right. Thank you.